Hey, boys and girls. We're here at Pratt Miller. Fabulous spot. I'm really impressed so far. And I'm here with Chris and Matt. And I'm here with Dave Foreman, who's with Munro Defense. And today we're going to give you a little bit of a tour on race cars, trophies. I've never seen so many trophies in my life. And we're also going to be talking a little bit about the defense work that Pratt Miller is basically getting into. So with that, can I have you guys maybe give us a little background? Maybe Chris, if you want to start, that'd be great, and sure. We'll go from there.
No, great. Thank you guys for having us. We're excited to do this today. I'm Chris Houghton, Chief Operating Officer for Pratt Miller, and we're excited to tour you through the Motorsports headquarters, one of the 6 buildings that we have here as part of our operations, where we support advanced product development in the defense, motorsports, and mobility markets.
Thanks, Sandy, for being with us. Looking forward to today. I'm Matt Carroll. I'm the CEO of Pratt Miller, otherwise known as the head cheerleader. So I get to cheer on all the great things that happen and take care of our customers and make sure everyone's happy with what they're doing and what we're providing for them. So looking forward to today.
Well, you know what? We cannot go any further until you take some shots of this absolutely stunning array of first place trophies. Okay, so there's a lot of racing that's done, and sometimes you get a little plastic cup like I did. But at the end of the day, looking at all this silverware here is just staggering. But the big deal is this one over here. Let's slide over here. I know we can talk about a lot of cars and whatnot, but let's talk about this grand prize that you got from your friends in France.
Well, as that is the tallest trophy, I would say it's not quite as important as the 9 trophies that are over there on that wall.
We're going to there right next.
Yeah,
but
so
this
this trophy
here
is from a few years ago where we jumped into what's called the World Endurance Championship, which is sports car racing on the global stage. And we hadn't typically raced in the WEC, as it's called, but this was a really good opportunity with GM for us to race the Corvette race team over there. And we were lucky enough to win the entire championship for that year. And as part of that championship for the year, we also won what we call the Super Bowl, which is the 24 Hours of Le Mans. So that's those 9 trophies there on the wall.
Yeah, well, let's slide over here and have a look at this. Le Mans is a big deal. I got a chance to basically sit in on Monaco and whatnot, but I wanted to absolutely see this, and you got 9 of these things. Why don't you give us a little detail on that? Because I don't think anybody in the States has ever won 9 Le Mans, have they?
No, not that we're aware of. We talk like, the words we use are, we are the most winningest sports car team in North America, if not the world.
Wow.
And so part of that is obviously those nine trophies. But that one there, all the way to the right, is very special. It was the 100th anniversary, which is what you can see there on the top of the trophy. So that was a really special win. Even more special than that was we basically, in the middle of the night, were out of the race.
How?
And well, we had a couple of challenges with the car. We had some contact, and the front right control arm broke. We had to bring the car in. Anytime you bring the car in a race like that, you're going down laps. And so we ended up being down 2 laps in the middle of the night. And with all the yellow caution and those kind of things, there are opportunities to catch back up. But wow. We just grinded that out. And by the time the sun came up, we were down 1 lap. And then as the race continued through the day, I think the end of the race was maybe 2 p.m. or 3 p.m. that day. Before lunch, we were back on the lead lap. And
wow.
And then we just kept grinding it out. And, with great strategy, great teamwork, and a great car, the Corvette race team was able to pull it off. And so we
So how many drivers did you have? Usually it's like 2 or 3 or something like that, right?
Yeah, for the shorter, call them sprint races, 2 hours, 3 hours, 6 hours, we have two drivers per car. But in this case, we have 3.
Maybe what you could do is give us a little background. That looks like a wind tunnel vehicle, so you test the aerodynamics and whatnot, and they kind of look like that's the baby, and here's the finished product.
Yeah. And so this all starts, with our partner GM, and so we have CAD with them, and so these race cars have to be developed in the likeness of those production cars. But we start with the CFD, which is kind of up there on that wall, and we'll take things as far as we can from a design perspective, and then from there we'll develop a wind tunnel model, a reduced scale wind tunnel model, and that's what you see there. And that's all built here as well. Yeah. And then that will come to a life where we start to build a test car. So we always start with a test car. Yeah. And then down in North Carolina, we have our drive in the loop simulator, which is, I would tell you, a super high fidelity. This is an F1 type level. The drivers get out of there and they're sweating. I mean, when they're in there, it's real. So from a development perspective, and this is what we've been able to morph into the other businesses, we will start with CFD, and we'll get to a point where we can run sessions where we've got folks in the tube, on the tube in there in CFD. We've got folks operating in the wind tunnel. We've got people, a professional driver at the DIL, the driver in the loop simulator, and a live track session, all going at once, running batch DOE in the cloud, where we can run models and do things on what might have taken you 6 months, years ago, you're doing it in 6 minutes.
Yeah.
Wow. So it's all live development, and it's really powerful stuff. And it's what we've been able to take into the defense world and how we do our virtual development and those kind of things. So it's really powerful having all those capabilities under one roof. I would tell you that wind tunnel capability was born in our support of the GM IndyCar program. And it's F1 level. I mean, it's really powerful to be able to utilize that, because when you start looking at things like electrification and commercial trucking, we got a project where we started working with a commercial truck company, and you start doing aero with them on a 40% reduced scale, commercial truck, and you start really figuring out range extension and other things that aero helps you with. So it's a great story of all the capabilities that Motorsports have led us into. No one purposefully said, hey, let's go there. It's kind of like the sport led us into these capabilities, right, and now we're able to use those in other product development areas.
Yeah, that was one of the questions I was going to have for you. First time I came out here, which was last year, we did a tour, and when I walked through the door, I was amazed at all of the motorsport that you had here, because I just wasn't aware of it. And here you are, right here in mid-Michigan. Who would have known that we have such history here? But 2013, you guys got into the defense. What led you to go from motorsports and saying, okay, we're going to get into the defense, we're going to start building UAVs, and how do you really tie the technology and other development that you're doing here into the actual defense vehicles that you're building and designing?
I'll let the guy who built the business talk more about that, but let me show Sandy something. Sandy, if you would, open this door. And this was a challenge that the U.S. Army had. Go ahead and open that door.
Oh, okay, this door weighs about an ounce.
Right. And so you see the light weighting, okay? So that's one thing, Dave. And then this right here is what we call a crash box. We invented that. It's filled with titanium, aluminum, honeycomb material. We designed that whole thing ourselves. This thing is taken up to a 56G hit, and the driver has just stood up and walked away. So that's survivability. And so in 2008, 2009, the Army was having a significant challenge over in the war zones with IED, blast, etc. And so they came to the community, in our case Motorsports, and said, hey, how goes it? How do you hit a wall and walk away? And so the lightweighting aspects of Motorsports and the survivability piece, and I'll let Chris talk a little bit more about some of the projects we did, like Camel, which is up on that wall, which is a blast project. But it's not a far commute from Motorsports to defense when you talk about problem solving.
Mm-hmm. Mm-hmm. Yeah, I think that Matt hit on definitely the entry point was protecting the driver, just like the soldier needs to be protected. And that all the tools that we've been developing in motorsports to do crash, to make sure that the driver's safe, we were able to port those over to become proficient in blast analysis and the different type of energy management, but still it's energy management. It's using the advanced CAE tools to predict before you start cutting metal. And we were able to very quickly port that over. I think the other big attraction from the Department of Defense was really just the speed at which we could do that. In motorsports, they say all the time the green flag waits for no one. So, you know, it's going green on that day, whether you're ready or not. It's always a rapid development cycle to get faster for the next race. That culture is just ingrained in our team and in our engineers, and we were able to bring that to our defense projects and be able to do rapid iterations using advanced CAE tools, translate that into prototyping and testing, and really come up with unique, innovative solutions very rapidly. And that kind of started our real diverse, what is now a diverse portfolio of defense work.
So why don't we get a little explanation from you guys on what's going on, how you're doing, whatever you can tell us anyway, and then we'll move down to that pin table. That's where I really want to get to. So
so this is our machine shop in our headquarter building. We do have machines in other areas of the business down the street, but this is our main machine shop. We just had a technical partnership established with Haas. So we've used Haas machines for many, many years, but now we've got a deeper, more meaningful relationship with them with the race program. And so now you see all these new machines. It's just fantastic for us. Our folks are so excited. These guys back here are unbelievable. These are artisans, right? These are craftsmen like no other, right? Only find in places like Southeast Michigan. And they are amazing. They don't get excited about anything. But when you put a new machine out here, they get real excited. So our team is super excited. This was established specifically for motorsports back in the founding of the company in the 90s, where we had to come back from the track every Sunday, and something's changing, whether it's a rule or regulation, or we broke something, or we're looking for performance. But being able to do this ourselves and machine our own stuff is really powerful. And it's something that we've made as a huge differentiator for all of our business lines, where we do use suppliers and other folks sometimes for parts, but for the most part, we do all of our fabrication as well in-house. So the machining is really important part of our business. We've got two cars coming to life right here. Right now, we're in the middle of building 20 of these cars. So we have the factory race team, which is a partnership with GM, where we run the factory team with them and for them. And then we also have a customer car program where we build all these additional race cars, and then those are sold to other race teams to race. So that we have a customer car program, and then we have a partial factory race program. So these cars here are all being built for customers. We'll go down to the bay down the way here in a little bit to show you the actual race cars that we race on a weekly basis. But these cars are coming to life right here on behalf of customers.
well, actually, I saw the cages up here. Are they the cages that are going on here to ultimately turn into what I see in back of me here, or in front of us?
Yeah, exactly. So those roll cages we've already fabricated. They're ready to go. And what'll happen is when we're ready with these two chassis on the plates here, we'll put those roll cages in, and we'll get going with getting the cars completed. And you can see down there in the back there, those are obviously well along their way with the roll cages already inserted.
So this is our composites bay. This is where we take dry carbon fiber material that you can see on the rolls here, and we cut that into the kits that are the sizes and shapes of the material layers that go into the molds. The team then will mix up the appropriate epoxy resin mix, wet out the carbon fiber and lay it into the mold based on the layup schedule for that particular part. We then put it, we wrap it and pull a vacuum on it to remove all the excess resin and pull the part down tight against the mold to make it dimensionally correct and as light as possible, and then put it in the oven for the right amount of time at the right temperature to get the right cure for material properties. And in the end, you end up with, you know, a mix of composite structure that's likely largely carbon fiber with some Kevlar in it in the appropriate locations if the design calls for it, for that strength and toughness that comes from the Kevlar. And you end up with, you know, like this Corvette door here that's really quite light.
This may weigh 2 kilos or something. Anyways, this is, let's everybody see the backside. This is kind of an art all by itself, knowing how to layer the materials and whatnot. Varnum is the other term used for vacuum molding and whatnot. But at the end of the day, you can see that there's inserts. Those are for screws that I'm not sure why you'd have them on there, but you can put inserts in here for screwing things together. And then also attached over there at the corners is where your latches and your door hinges would go.
So Sandy, that's a digital
almost
number system. That's a digital number so fans and people can track the position of the car on the track.
Oh, I see. Cool. But anyway, at the end of the day, people only get a chance usually to see the outside skins, and then but seeing what it looks like underneath is kind of a big deal. And if Grace, can you come over a little bit? If you can look down here, you can see that the grain structure on this is different. You can see that the mesh here is going in one direction. The mesh there is going in a different direction, and over there it's going in another different direction. So you've got straight, angular this way, angular that way, and then another angular here, but you can also see that by the pattern, it's not quite the same carbon fiber. So we don't usually get a chance to see how something is put together, but this is more aircraft, more of an aircraft design than it is what we would see normally with SM's sheet molded compound, where we just come down, squirt, boom, dang, and here's your part. This is like a very exotic, and it requires a high skill level for the operator to put together.
So this is the body buck, we call it. So this is the quality check for all the carbon fiber body panels. So all of that we build get brought to this buck. Everything with an orange sticker is the master part. And what we're doing here is making sure that the parts all fit on the master car. Because we are now, as we're building 20 cars for teams across the world, we're sending parts all over the world. They need to fit, they need to go on the right time, they need to go on very quickly in a pit stop type situation. So that's what this area is now, like the final quality check and shipping area for sending parts all over the world for the Corvette race GT3 customers.
So in the olden days, it used to be you'd bring tin, baling wire, and a lot of duct tape, and when things went wrong, you banged around, bent things into shape, sometimes welded, not very often, but duct tape and whatnot. But in modern racing, quarter panels disappear and new ones come on, and they always fit perfectly. And one of the nice things about carbon fiber is it's like working with a stone. I love this stuff. I absolutely love things that come together perfectly, and carbon fiber is the best, as far as I'm concerned, for always giving a good quality build. Yeah. So is this what I'm seeing here? I see the parts going on. That's the master. What am I looking at here? Are these new bits or something?
Yeah. So if it's not marked with a sticker, it is something it's a part that's in the middle of being just tested for the fit. And the rest of this area does final assembly. So we'll get a door without the window, without the hinges, without the latches on it. These guys will build it up and prepare it as the final part, including barcoding and serializing to get it ready to send to the customer.
This is the race bay. This is normally where you'd see all the mechanics, truck drivers, etc. We would normally have big transporters over here on this side, but literally just before we walked in here, they drove away They're headed to Indy. We've got a race this weekend in Indianapolis.
Cool.
So that's the second to the last race for this year. So this is normally buzzing, and things aren't ever put together. When we come back from the track, these are stripped down, looking more like something like that chassis.
Yeah, this is a thing I wanted to point at next after, well, it's all put together, but that's kind of like where you get started, I think, eh? So is this something that is after a race, or is this like being prepared for a race?
Yeah,
Or
so
do you know?
it depends on, after an endurance race, we will tear down to this level, basically.
Yeah.
Bodywork comes off very quickly. Engines, which GM does all of the engine design, build, calibration, comes to the track and manages the performance of the engine and the calibration of the engine at the track. That's on their schedule for a rebuild of the engines, depending on if it was a short race or a long race. That contributes to the engine schedule. So that complete powertrain will get removed. The engine inspection and rebuild will happen, and the whole car will go back together. We monitor the life of all of the parts, so we know how long a control arm should last, and those are serialized. We track those in our own vehicle engineering system software, so we know when parts are lifed out and need to be changed. So it really just depends on the schedule for lifing out parts and engine rebuild, to what level a car gets taken down to between races.
Well, I'll tell you, I understood everything right up until you said that the GM is in charge of the engine or the powertrain. I'm guessing the engine transmission, right? That's a surprise. I guess with F1, nobody touches those engines except for the F1 owners. How do you work that out? Like, is that done because of the rules and regulations that are associated with the Racing Commission, or because it has to have some GM content, or is that something that you just automatically have been doing?
There definitely is certain content rules, but in our partnership with General Motors and what's important to them as far as development contribution and tech transfer, the powertrain design is an element that they wanted to keep, maintain, own, be able to do tech transfer. The engines are based on the Z06 engine, so it's a 5.5 liter flat plane crank engine. It uses a lot of production parts in the engine itself.
Really?
So there's a lot of learning that GM's doing on the powertrain side from running the race engine program. So that's part of our Corvette Racing by Pratt Miller Motorsports agreement with General Motors, is them doing the powertrain and the car going to the track as Corvette Racing still, as it has for many, many years now.
Wow.
You mentioned earlier that they're really looking to drive a lot more content into the race vehicles as what's going on to a production vehicle as well, correct?
Yeah, I mean, I think generally if you were asked executives or other people who approve motorsports budgets at other companies, you know, there's a lot of purpose for why you race, and one of those is certainly tech transfer. There's no doubt about it. And a lot of people would say it's talent, you know, attraction and recruitment. It's branding, or it's awareness of the product, and which sports car definitely is. But if they're not doing any tech transfer, you know, I was on a panel a couple weeks ago with the gentleman who runs Honda Racing, and he would say the same thing. He said, you know, Mr. Honda, I forget his first name, Mr. Honda always would say, without racing, Honda doesn't exist.
Well, Honda's an engine company that happens to make other things. So that's kind of like the way they're looked at. So you were saying that's why people race. Can you maybe explain to me why certain companies don't race? What, have they lost their mind, or are they strictly finance focused, or what is the reason for that? I never could understand it.
Yeah, I think having been acquired by Oshkosh 3.5 years ago, I think we bear witness to exactly that answer. They weren't in motorsports prior to acquiring us, and I'm not sure they could even spell it. But their new CEO came from Mercury Marine, and
really?
Yes, and so the Formula One marine boating program for Mercury is, you know, world class.
Yeah.
He understood what racing did for that company.
Yeah.
And so I think it was a short commute in his mind for how the motorsports platform from Pratt Miller made a lot of sense. But I think if you went to a traditional company and asked them why, they're going to tell you because it costs money and I don't know what the ROI is. And so it's really the fuzziness about what is the ROI. And a lot of times I think in racing the ROI is probably not as apparent as other investments you might make. But there's certainly massive ROI. As we see it, there's massive ROI, and why we try and get sponsors obviously on the car who understand that equation of how many views do you get on TV and those kind of things. Sure, there's a lot of that, but I think there's also a branding element, and there's a technology influence and spirit piece of that too. Your people think differently when Chris had mentioned earlier, you can't kind of be ready when the green flag drops.
Right.
Well, if I look at the defense market that we're in, the mobility, we treat it the same way.
Yeah.
Absolutely.
We can't kind of have this ready for our customer. It has to work the first time and every time.
Well, I don't know about ROI, but I know how you can diminish your sales, get out of racing.
Yeah.
It's amazing how many people have done things like that for, and sometimes a short period of time, like somebody says, okay, we tried that, get back in. But other companies, they just, oh, look at the money we're saving. I'm going to get a bonus. Somebody gets a bonus, I know that. But then your market share shrinks, your reputation shrinks, or in some cases vanishes. It just, to me, it was always been, why in the world would you do that?
Yeah.
But I'm not, again, I don't have an MBA, just a toolmaker.
But I do think there are educational things. Like I would tell you, there's probably a lot of folks in Oshkosh that 3.5 years ago prior to acquisition wouldn't they'd say, why would we do that?
Yeah.
Well, we took the camera system that we invented. So you mentioned earlier, we're doing 200 mile an hour. Well,
Yeah.
some cars are doing over 200, some cars are doing 180, all the different classes.
Yeah.
It's challenging out there in the middle of the night, on the back straight, in Le Mans, in the middle of the night,
Yeah.
where it's dark as dark, and you can't see any, and you got people coming up behind you, or you're coming up on folks. We invented a camera system called CAMs, where we're able to give cueing to the driver and direction to show him where the threat is, or or if he's coming up around somebody. We're putting that camera system right now into fire trucks. And if you think about it, the first 10 minutes of a fireman's life after a call, he's a race car driver. She's a race car driver.
Right.
Going down the street. And so this system we're putting into the Pierce fire trucks right now, which is the Oshkosh. And it's things like that where we're inserting things from racing into other products, which people kind of get that aha, wow, that's pretty powerful stuff. Because right now, very dangerous jobs that Oshkosh supports.
Oh, absolutely.
The refuse truck business, super dangerous job. Working at height, construction equipment, super dangerous. The firemen, the rescue stuff, those are all super dangerous jobs, and we're trying to help make their jobs easier by virtue of some of this technology that comes out of motorsports.
Yeah, the situational awareness around military vehicles, all the cameras, the sensors, the environment that you're in when you really can't see, whether it's fog, smoke, rain when you're racing. That technology transfer is incredibly important. It was an interesting thing because you're a defense company as well. Later, you're a defense company, and then Oshkosh came in and purchased you guys somewhere around 2020, and so they're taking advantage of all this technology.
I mean, all the autonomy we've got in defense. We've got, I don't know how many unmanned platforms, 4 or 5 anyway.
Yeah.
Unmanned robots and significant platforms, 7,000 pound type platforms, not little. And that autonomy capability we've ported into other products for the Oshkosh NGDV, the postal truck. We help handle all of the visioning systems and the telemetry, all those things that are in there, the infotainment stuff, and a lot of that came out of defense. So we're porting learnings and capabilities all over the place, and again, it was all born here in motorsports.
Okay, so this, believe it or not, is an assembly line. And we're going to hear about how this all works.
Yeah, so this is where we do the bay builds for the GT3R Corvettes. So this is 4 bays of build and 1 bay of other assembly work or repair. We run a pair of cars through at the same sequence of build. So there's 2 pairs of cars going through there, and we build 1 car about every 8 weeks through this bay build process. They don't move bays, they stay in a single bay and go through the entire work instruction book in a single bay.
So it's the people that move, not the cars.
Correct.
Yeah. So the opposite of an assembly line, but this is basically how you made an F-16, F-18. They stay in place, and the teams, the assembly teams come and work on them. Makes it for a much smaller factory, a smaller footprint, and quite frankly, I've never ever really understood why someone would go to an assembly line for low volume. It makes no sense whatsoever. But this is quite extraordinary. If you look all the way down there, you can see, in essence, the body with a roll cage on it, and then a little bit right next to it. Okay, there's a couple of pieces of carbon fiber. This one over here has got some glazing on it, and then over here you've got one that's slightly behind that one over there. So and you've got the teams moving from one to another.
Yeah.
Yeah.
So is the team trained on the entire build process, or do you have teams that are very specific to a portion of the build, and they kind of index between the builds?
So in general, they're in a work team that knows the whole vehicle. So there's some leaders that are experts on every part of it that are available, will assist and guide the whole process, but essentially a team in a bay is building the entire car. And we've really tried to apply some of the lean manufacturing principles to our basic inventory, which is on the other side of the room, and then halfway between where these cars are in the inventory, we have sub-assembly build areas. So there's sub-assemblies that are done to build up an upright corner or build up a certain portion of the vehicle that then brought here to the final assembly bay.
So you have module build. Those sub-assemblies are modules that you can stick on. Makes it less complicated and crowded here in the main assembly area. Dare I ask, how much is one of these worth? Or let me rephrase that, not worth. What are they? Because they're priceless, right? But what do you sell them for? How much in general? What do they?
Yeah, I believe the price tag is about $750, Dan. Yeah, it's about $750,000. That's the base,
wow.
And then you got kits and spares and those kind of things.
Yeah.
But that's for that class. I think that's in the middle of the class range.
That's a hell of a buy when you compare it to F1 racing and whatnot. That's the buy of the century. $750,000. All you rich guys out there that want to have the coolest thing in your garage. The neighborhood doesn't probably have a whole number of these, so this would be $750,000 for some of the people that I bumped into. Would be a drop in the bucket. I'm not in that category, but if I was, I certainly would love to have something like this. Yeah. Chris and Matt, thank you very much for an unbelievable tour. For me, watching the process that you guys go through was phenomenal. Your teams are small, but everybody seems to be able to crank at a ferocious rate. Your successes, I mean, you walk in this place and you're loaded with trophies, first place trophies. Coming out here, looking at a machine shop that most tool makers would die for, and then ultimately putting it all together and doing it again and again and again in every racing field imaginable. I'm just totally blown away. This is and I hate to say this, I'm going to look like a real fool, but I had no idea, none. You guys are stealth. I'm not 100% sure why Michigan hasn't been pounding their chest about this application, but maybe more people in Michigan should know about what's going on here, and your absolutely fabulous little company. Not little, it's quite big based on what I'm looking at here and what you can crank out. This is amazing. So thank you so much for for giving us this tour and for educating me. Yeah, this was really, really good. Really good.
Yeah, we've been looking forward to it. We're big fans of Munro Live and what you do, Sandy, and so this was deeply meaningful for us to be able to host you. And one of the things that we are trying to do, quite honestly, as a company is get the word out. We kind of, you know, we've been an exclusive partner to General Motors, which was just an amazing thing for us as a company to be able to live and learn with such an amazing you know, company that's well known on the world stage. But we were kind of you know, in the back seat a little bit there, and very proud to be part of the Corvette racing and Chevrolet and all that they did. But today we're in a different space, so which is we're trying to get more awareness out there, particularly as we have moved into defense and mobility, not just in racing. I think those that know us from racing know Pratt Miller, but it's not nearly as well known as we would like in the other markets that we serve. But yeah, it's great to have you come and see this and say those kind of things.
So I was going to ask, Pratt Miller is associated with Oshkosh. Oshkosh, or is owned by Oshkosh. And Oshkosh is a huge defense contractor. And I was just wondering if Dave, you might have, because we unfortunately can't go in and film there, but maybe Dave could talk a little bit about what he might like.
I toured the defense business last year. Very impressive. You guys are doing a lot of work on the autonomous vehicles. You know, looking at, you know, a commonized platform where you can actually modular different weapon systems or other things on there is very impressive with what you guys are doing and really tying in the electrification to that whole entire system. So if you can talk about what you're doing in that area and how it is that you actually decided that, you know what, we're going to go from this high-end sports car business and we're going to jump into the defense business, because we basically did the same thing.
Yeah, for us, I think, you know, it goes all the way back to 2008, 2009. Jim Miller had the foresight to see that there was some economic challenges coming, and at that point we really had one customer in General Motors, and so that began a business strategy to say we should diversify. That journey then got into what we've talked about a little bit today already, which is what are we doing in motorsports that immediately translates to defense in terms of lightweighting, survivability. And as we got into it, we've been able to keep going with expertise in lethality, survivability, and unmanned systems, and that's really been our growth areas within defense has been in those areas as we've developed specific defense expertise in that area that didn't necessarily come from motorsports, but is now very defense specific expertise that we have.
Yeah, we've been having a lot of discussions with several different groups. You had mentioned that you're also part of the Lawrence Tech University Centropolis. I am as well, and Munro's proud to support those efforts. But you know, we really look at Southeast Michigan, as you had mentioned, the amount of technology, universities, prototype houses, and just the overall capability that we can bring to the defense industry is truly amazing, especially when you look at the advanced technologies a lot of these small unknown companies are doing, and at the speed, and how do we really bring all of this wealth of knowledge and capability to provide our, you had mentioned it earlier, you know, weapon systems or vehicles to the warfighter that work every single time. There is no choice. When you turn something on, it needs to turn on. When you pull a trigger, it needs to fire. It's incredibly important. So, you know, we started the Munro Defense business really to take what we would consider some of the world's best practices are developed right here in the automotive community, right? And how do we take this knowledge and bring it into defense systems?
So actually, the summation is that at one time, Detroit area was looked at as the arsenal of democracy. It still is, but we don't have that title anymore because over the years people have thought that it was out of style or something. I believe that I bumped into a slight epiphany when I saw one of those posters, one of the old World War II posters, calling out Detroit as the arsenal of democracy. And from that and a couple of other things, I went on a trip and I said, I want you to build a wall here, and that's going to be our defense group. And a lot of people came along and said, what are you talking about? We don't have any defense contracts. We gave up all that stuff. We don't do it anymore. Well, we're going to do it. And then I went around the world giving speaking engagement in 2019. When I came back, the walls were up, but it wasn't done. I got really unhappy. And then I made Dave the unhappiest guy on the planet by telling him, okay, you were in charge of software, not anymore. Now your job is to go out and get us into the defense world. So from a marketing, sales, whatever kind of standpoint, Dave did exactly what I asked for, and now we're moving just like you down that path. And in the next couple of years, I believe that defense is probably going to be even bigger than commercial for Munro. How do you guys feel? Do you think that you've got the race car business for sure? You're doing something over here with Oshkosh. Do you think there's going to be something new that's going to even build your area of the company up bigger, or what's your future plans, I guess?
Yeah, I think, if I looked at it in a vacuum, meaning we weren't part of Oshkosh and a bigger family, I think we could absolutely build bigger, deeper in the defense space. But I don't think those are our desires. Our desires are to be a more balanced company. Skunk works on behalf of Oshkosh. So balance motorsports, balance defense, grow mobility more, to be more of a equal footing for all three of those businesses. But as a guy that came to this company 8 years ago, I couldn't spell motorsports. I came out of the defense space. I was an aviator in the Marine Corps and got into the corporate world through engineering company and lived in DC and lived in the Pentagon and lived in Afghanistan and Iraq for a living. And I would say that folks who get into defense, really the challenge is finding out where your best value is, because there can be a lot of frustration in the big machine. And I don't ever want to sell pencils to the Pentagon. I mean, there's a lot of folks out there that are caught up in that, because it's $800 billion that they spend, right? So for us, I think we've been able to find the niche values that we bring significant technology to the warfighter. And if you can figure out what that recipe is, as a defense company, I think it allows you to penetrate more surgically. Where we don't do a lot of work for Big Army. We work for GVSC, we work for Marine Corps Warfighting Lab, we work for ONR, we work for the DARPAs and the labs. And not to say that we don't work for bigger entities, but typically it's the primes that we started with, and the labs, the folks who are willing to take chances on the things that we do, which is usually on the front end, earlier on in development. And the procurement system for the government is a challenge.
Yeah.
And so that we try and find our way into places that aren't as bureaucratic or aren't as fraught with red tape, which is really, we find a great place to live and be very creative with our customer. Our three goals, I know Munro 3 rules, our 3 goals, Jim Miller put these in place: customer satisfaction, employee satisfaction, and financial stability. And we find we can do that with the right partners in defense.
At the end of the day, you're looking at electrification for the defense world. You've got wicked fast cars that win a lot. Where are we, or where are you with electrification of race vehicles, or electrification in general for The automotive industry or the racing circuits?
Yeah, electrification is a huge part of the work that we have been doing, and a lot of that work for us now is changing into range extension. So what does that look like to not only continue to help our customers design the best EVs, but also what are the range extension technologies of the future? And as we said, a lot of that is focused in hydrogen right now, but there are other solutions for power and energy and range extension. I think from a motorsports standpoint, we are ready because of all the work that we do for our commercial customers. We're ready with the skills, expertise, and knowledge of what's going on in the market to apply that to the sanctioning bodies and where they go with the rules. But that really will be largely driven by the rule makers and those sanctioning bodies that'll determine when you'll start seeing more than Formula E and more than the off-road electric series that are currently running.
Well, you got the NASCAR. I was at the NASCAR series where they unveiled the first electric NASCAR. I was standing right there when they took off and whatnot. I can't begin to tell you how shocked I was. And I've been driving electric cars for quite a while now. I couldn't believe how fast that thing took off from the line. And I heard that the driver, he's a real driver, and they kind of said, no track records, okay? Because when he took off and zipped around, I thought, that's the fastest lap I've seen here today, but they didn't know. And I saw, a lot of different racing. NASCAR's like 2 solid days, three solid days. And I was blown away when I saw that thing whip around. How long it could do that, that's another question, but I see a lot of people being enthusiastic about losing the roar of the engine and watching something that's maybe half again as fast zipping around the track. So
Yeah, I personally think that it'll coexist. I think,
I'm positive of that.
And then we're going to have a window of hybrid electric, which we have right now, right? Our top class is called GTP or hypercar. That is right now hybrid electric. But with all the other work we're doing in we've done commercial truck EV, we've done power sports EV. By the way, this power sports, side by side, 0 to 60 in 3.2 seconds.
Yeah.
That's just crazy.
Yeah.
But again, how long can you do that for? But EV in the defense space, so we'll be ready.
Yes. So on that happy note, I have facial expressions that say that we should be wrapping this up. Anyhow, we could probably go on here all day long, but I'd really like to thank you guys for this absolutely brilliant tour. All the success in the world. You guys are doing a phenomenal job.
Thank you.
Thank you.
Thanks, Sandy.
Thanks so much. And thank you for
Thanks,
watching
Dave.
Munro Live.